Hi guys, today we're going to talk about something called Ohm's law. This is the first thing you need to know about electronics. It's fundamental and it's easy. It's easy to comprehend and it's likely one of the only mathematical things you always got to keep in mind about electronics. So what Ohm's law is a triangle. E over I times R. E stands for voltage. I stands for current. And R stands for resistance. Now the way to understand this triangle is this. You always need two variables in order to determine the third. So if you have one variable, you can't find the other two. You need at least two to find the third, but you can always find the third if you have two. And here's how the triangle works. If you say you want resistance, you have the voltage and the current. R equals E over I. If you have the resistance and the voltage, but you need to find the current, you know the formula is E over R. If you have the current value and the resistance value, but you're looking for the voltage value, E equals I times R. So I hope this is, let's just write this out for fun. E equals I times R. E equals I times R. R equals E over I. And I equals E over R. So, let's look at the three of these things. They all work together. Think of current as a hard ball. Think of voltage as how hard you throw the ball, the force behind that hard ball. And resistance is the factor controlling the amount of hard balls that are being thrown. So let's look at a circuit here, a very simple circuit. This is the symbol for a single cell DC battery. Plus and minus. We will look at a unit with a single resistor in it. Now this is the universal symbol for a resistor. There are other ones, but this is more commonly known. Okay, so if we've got 10 volts along here, and say this is a 10 ohm resistor, that's a very small resistance. How do we find the current flowing through this resistor? Of course, we go I equals E over R, which is equal to 10 volts divided by 10 ohms. Now before I forget to mention, the omega symbol is a symbol for ohms. Resistance is measured in ohms, current is measured in amperes, and of course voltage is measured in volts. So 10 volts divided by 10 ohms equals 1 ampere of current, 1A. So whenever we're trying to decipher a circuit, I find the easiest thing to do is always make a table. Now here we didn't really need to because we were only missing the variable of current. But if we wanted to, just for the sake of making a table, here's how I would personally go about it. And I found this saved me a lot of time in school. Let's just do it over here. Always set up a table with however many resistors you have. Now this is a series circuit. We're going to talk more about series circuits in a minute. But since we only have one resistor, we'll label this R1. E, I, R. And we fill in the value. So starting off, we knew that there was 10 volts. Shit. All right. So this is an example of a series circuit. We're going to talk more about series and parallel circuits in later labs. But since this only has we were missing one variable, it's easy. We don't need to make a table to solve this puzzle. The puzzle being finding the value for current in this circuit. But since we're doing this, we might as well try to go about making a table of this, just to help solve a circuit. And I found a way to do it that really helped me understand it in school, and actually made things a heck of a lot quicker. Now remember when I say you always need two variables to find the third. So let's go up here. For this circuit, 10 ohms, 10 volts. We knew we had to find the current value, which we've already found to be 1 amp of current going through that resistor. But let's make a table for it. There's only one resistor here, so what I would do is write down R1. There's only one resistor, so I'm going to say R1. Set E for voltage, I for current, and R for resistance on the left of the table. Fill in the values that we knew. So 10 ohms of current for R. 10 volts for voltage. So we know that we've got vertically 2 of 3 variables. So what we know is I equals E over R, which happens to be 1 amp. So let's erase this and try again. Let's change this circuit up a little bit. Say 1 kiloohm. Now whenever I say killi anything, I mean 1,000. K equals 1,000. So 1 kiloohm is 1,000. 10 kiloohms is 10,000. 100 kiloohms is 100,000, and so on. Let's say we've got 100 volts. So let's make our table. R1, E, I, R. Let's fill in what we know. 1 kiloohm, which equals to 1,000 ohms, and 100 volts. Bring out your trusty calculator and simple arithmetic. 100 divided by 1,000 equals 0.1. So instead of putting 0.1 amps, what you can do is you can say 100 milliamps if you want to. We're just going to say 0.1A. But what 0.1A means is 0.1 amperes is also equal to 100 milliamps of current. So if we had 0.15 amps, it would equal 150 milliamps. If we had 0.395 amps, it would equal 395 milliamps of current. So I hope you understand how the table works. What I'm going to do now is I'm going to pause the video and I'm going to erase the table so we can start a new part of this lesson. Alright, so what we're going to do now is we're going to talk more about series circuits. First I'm going to draw out a series circuit, and I'm going to tell you the main characteristics of a series circuit. We're going to put our DC battery supply. This is a single cell, positive and negative. Now just to add a small note, if we were putting several batteries in series with each other and wanted to put it in a schematic symbol, this is a multi-layer, positive and negative. I'm going to erase this. We're just going to say we've got a single cell 9-volt battery. we're going to put a resistor here, in series with another resistor here, in series with another resistor here. And we're going to say 3 kiloohms for R1, 3 kiloohms for R2, 3 kiloohms for R3. So, first things first, let's talk about the main characteristics. Voltage in a series circuit is cumulative. By cumulative, if we didn't know what the total voltage was, but we knew the voltage across R3, R2, and R1, we add those together and we find the total voltage. Same goes for resistance. If we don't know the total resistance, but we know the resistance of each of the 3 resistors, we add them together and we can find the total resistance. Now, current is common in the series circuit. I'll show you what I mean in a second. First things first, we're going to make a table. This one's going to be R1, R2, R3, and totals. Voltage, current, and resistance. So first things first, we're gonna put in what we know. We know that each resistor for R1, R2, and R3 are each 3 kiloohms. So remember, that's 3,000 ohms each. 3K, 3K, 3K. We also know that the total voltage supplied to this circuit is 9 volts. So that's our total voltage. Alright, so the next step would be we need 2 variables to start anywhere, right? And for every single one of these, we only have 1 variable. So what do? We know what our total voltage is. We know that if it's a series circuit, we add all the resistances together, we find the total resistance. So 3K times plus 3K plus 3K is 9K, 9,000 ohms. So let's add that in. Great. So now we can find total current. And remember, I equals E over R. So 9 volts, we're going to say I total equals 9 volts over 9K. Again, bring out your trusty calculator. 9 divided by 9,000 equals 0.001 amps, or 1 milliamp of current. So 1 milliamp, or let's just put 0.001 amps. Now, as I said, once you find the total current, or any current value, if you have 2 variables anywhere, and you find the current value, you know that that is the value for every single resistor in that circuit. Current running through here is the current running through here is the current running through here. It's common. It's not cumulative. So that's great, because once we find a current value, we can add in current values for all along here. So let's do that. 0.001 amps. 0.001 amps. 0.001 amps. So now look, we've got 2 variables for R1, 2 variables for R2, 2 variables for R3. So we can find the voltage values across each of the resistors. So let's use our calculators. E equals I times R. Remember the triangle. E equals I times R. So 0.001 times 3,000 equals 3 volts. And since all the values are the same, let's do it again. 0.001 times 3,000. 3 volts. Same thing here. 0.001 amps times 3,000 equals 3 volts. 3 volts plus 3 volts plus 3 volts equals 9 volts. So you see, the total voltage in a series circuit is cumulative. R1 plus R2 plus R3 equals voltage total. Same thing with resistance. 3K plus 3K plus 3K equals 9K, total resistance. If we had, you know what, let's switch this up a little bit. Let's erase this, and we'll mix our circuit up a little bit. We'll change our values. Okay. Okay. 1K. We're actually going to change this again. Here's a good way of doing it. We got 1 kiloohms of resistance at R1 and 5 volts dropped along it. We've got 2K ohms across R2, and we've got 10 volts. We've got 3K ohms for R3. So let's add in what we know, okay? 1 kilovolt for 1 kiloohm for R1, 1K. 2K for R2, 3K for R3. Pardon me, my omega symbols aren't up to par. Okay, so we also know that there's 5 volts along R1 and 10 volts across R2. So we've got a great head start. This is a great circuit. It may look confusing, but look at this. We got 2 variables here, 2 variables here, and we've also got all 3 resistances. So that's great. Look at this. 1K plus 2K plus 3K equals 6K ohms total. We don't have the third voltage variable, so we can't find total voltage just yet. But hold on. 5 volts divided by 1K, remember I equals E over R. 5 divided by 1K, if you throw that in your calculator, 5 volts divided by 1000 equals 5 milliamps. Now, we've got a current value, so we know that the current here is equal to the current here equals the current here. Check this out. 10 volts divided by 2K. 0.005 amps. So you can check it out. I'm not making this up. 0.005 0.005 amps. Remember, current is common, so you find one current value, you got them all. So now we've got 2 variables for R3 and R total. So let's do it. E equals I times R. Remember, E equals I times R. So 5 milliamps times 3000 equals 15 volts. Now we can find our voltage total 2 ways. We can add it up. 5 plus 10 plus 15 equals 30 volts. But why not do it this way? E equals I times R. 5 volts, or 5 milliamps times 6K. $30 volts. So Ohm's law works together. If you ever have 2 variables, you're golden. So I hope this has provided some insight as to how these circuits are working. You might think, when am I ever going to use this? Trust me, if you keep watching these lessons, you're going to understand. You're going to see what all sorts of great stuff you can do with it. And I'm actually going to show you right now. I'm going to show you a board I've been working on in some of my next videos. We're not using this one, but we will be using it for some other ones. Please take a look at my eBay store. I hope that the $1 you spent on this was well worth it. There are going to be tons of other videos. So before I leave you, I'm going to show you my board, and that'll be the end of this video, and I hope you come back for the next one. Thank you very much. Thank you very much for your patronage. I do appreciate it, and I hope this video was worth it for you.